Hello friends, in this part of the video for differentiation 1 for mathematics preparation for IIT-JEE, we will be discussing some example problems of continuity and differentiability. The idea behind these problems are that these are very simple problems and these are the first step for you to start understanding how we will go about solving continuity and differentiability problems. So let me first start by giving a very quick example, very quick questions. So the question says, discuss the continuity and differentiability of ax square plus bx plus c, where a, b, c are real numbers for x belongs to R. Basically, x for all the real numbers, discuss the continuity and differentiability of a quadratic function. So we have already discussed this. I just want to reiterate here that whenever you see a polynomial of any degree, you can just directly write that these are always continuous and differentiable. Okay, so this is I just wanted to very quickly talk about this so that you have an idea of how if you see something like this, you just don't even have to solve it. Similarly, if you get something like a sine square x plus b cos x, and again x belongs to R, how will you solve something like this? You can again very quickly just directly write that these are also always sines and cosines also are always continuous and differentiable. I have discussed this before. The idea was just to repeat that in this video so that you get an idea of, just you again recall and that you don't forget that if you see something like this, you don't even need to do any calculation. I mean, this is a very general example I have written. What if you get something 3 sine square x plus cos cube x or something like this? So you don't have to take derivatives, you don't have to try to understand anything. Sines and cosines, all powers are always continuous and differentiable, similarly for a polynomial. Now, I have talked about sines and cosines. What about tan functions? So a question asks us to discuss differentiability and continuity of tan x for x between minus pi by 2 to pi by 2. Okay, minus pi by 2 to pi by 2. Now for this problem, like I say, whenever you know a graph of the function, just sketch the graph. It is the easiest thing to do, and you can very quickly see whenever there are corners, it is not differentiable. Whenever there is discontinuity, it is both discontinuous and not differentiable. So let us make the graph of tan x, and this is x, this is y, this is pi by 2. The question asks us in terms of between minus pi by 2 to pi by 2, and as you might already know that tan x graph looks like something like this and something like this. Okay, so if it is something like this, then, and the important part here and why have I basically given this problem is that these are circular brackets, so this does not include minus pi by 2 or pi by 2. So in this case, between this part, the function is both continuous and differentiable. There is no break. It's a very smooth graph. So the answer is that yes, both continuous and differentiable. So this is also both continuous and differentiable. However, what if we do something like this? For x between minus pi by 2 to pi by 2. So now I have included in the square brackets minus pi by 2. So now in this problem, this point has been included, right? So because this point has been included, you know that at minus pi by 2, at x is equal to minus pi by 2, because cos of minus pi by 2 is 0, then tan x is not defined, and because it is not defined, it can never become equal to anything, and hence it becomes discontinuous at this point. And anyway, we cannot define the left hand derivative of this point, but we cannot even define the right hand derivative of this point. So we will say that the function is discontinuous, and because we cannot even define the left hand derivative of this point, so differentiability makes no sense. So this function is discontinuous here, and differentiability does not have any meaning here because there is no left hand derivative or right hand derivative. But in terms of continuity, because continuity means that you can find if we want to find the continuity at this point, it would mean that the function value is equal to the right hand limit. There is no left hand limit, but at least it can be equal to the right hand limit, and in that case, because that is not happening, it is discontinuous. Okay, so this is just to give you an idea that tan x is not continuous. Let us say if I make it minus pi by 2 to 3 pi by 2, then it includes pi by 2. Again, this will become discontinuous as well as not differentiable, because both left hand limit and right hand limit are different, and there is not defined at pi by 2. So tan x is not similar to sin x and cos x. That was the idea, and I hope you understand, because the value is not defined. Okay, so now let's go and talk about greatest integer of x. We have done a similar problem in the last video, but just to recall again, between x belongs to 0 to 2. Sorry, this is circular bracket. Okay, so again we know the graph for x belongs to 0 to 2 of greatest integer of x. So we can quickly draw the graph. So we can very clearly see that here there is a break in the graph, and the rest of the graphs are just straight lines. So this would mean that discontinuous and not differentiable at x equal to 1, because whenever the function is discontinuous, it is not even whenever the function is discontinuous, it cannot be differentiable. So we don't even need to evaluate LHD, RHD. So I am giving very simple examples in this video. In the next video, you will see that there are more complicated examples. So let me start by giving you some more hint of what kind of questions you will actually get in JEE. So one of the problems that I have written here is find for x square minus 4 mod for all x, discuss the differentiability and continuity. So for this part, you should quickly recall that again you can draw the graph of x square minus 4 very quickly, because you have done that this thing in chapter functions. So what is the step 1? Step 1 for drawing a graph like this is that you first sketch without the mod x square minus 4. X square minus 4 is a parabola with face opening upwards, because the coefficient of x square is positive, and the intercept here is minus 4, because at x equal to 0 the value is minus 4, and here at 2 and minus 2 you can sketch the parabola of parabola something like this. Now because you have a mod in terms of when you have the mod for the entire function, you flip it along y-axis, because whenever the value is negative, it will basically sorry, this was minus 2, and this will become something like this. Okay, so this is the final curve. Right, this is the final curve of mod x square minus 4, and you can very easily see that at x equal to 2 plus minus 2, it is not differentiable. However, it is continuous for all values. Continuous for all x. Okay, so I hope you understood it from this video how that all polynomials, sines, cosines are differentiable and continuous. When you get functions like tan x, whenever there is not defined, they are discontinuous and not differentiable if that is the entire point is included in the domain. Then you have greatest integer function of x, whenever there is discontinuity, it is not differentiable, as we have discussed in the last video. And finally, if you get something like in terms of a quadratic or some function which you can sketch, just directly sketch the graph and take the in terms of mod, just directly sketch the graph and search for corners. So I hope you can remember that we said that these are not differentiable here because there are corners at minus 2 and 2. So because there are corners, it is not differentiable, and it is continuous because there are no breaks in the graph. So I hope this gives you a taste of how you can approach these things graphically. we'll do much more complex problems in the next part of the video. This was just to give you a flavor of the problems. Thank you.